Today we're looking at the volume of prisms and specifically right prisms. Now firstly, for the purpose of this video, we just need to identify that I'm referring to a right prism as prisms that have two identical parallel faces where all the cross sections of the prisms between these two identical faces must also be exactly the same. So in other words, if I slice through my right prism between the two identical faces, all the cross sections look like those original identical faces. The sides will be perpendicular to the base. That's why they're called right prisms. So this formula that we're looking at today is not for cones or pyramids or spheres. So what's going to happen here, we're just going to look at a few examples of right prisms, and you'll see in each of these examples they have a face that you can see they've got a matching one on the other side. So in my triangular right prism, the triangle at the front matches the triangle at the back, and any cross section in between will be identical. In my cylinder, we have a circle at the top and a matching one at the bottom, and wherever you look, the cross section in between will be an identical circle. And my one in the middle bottom here, we have a trapezium as my base. Again, there is a matching one at the back. We can't use this little rectangle at the top or the big rectangle at the bottom as the base, because obviously the one at the top is bigger than the one at the bottom, so they're not identical faces. In this irregular prism over here, my base of the right prism is an irregular shape, but that's okay because the one at the bottom is identical, so my base is this funny shape here. In my rectangular right prism, any of the faces could be used as the base. I have just selected this one here. It doesn't really matter. So we need to look at the formula for any right prism, and this is always the area of the base times by the height. Now obviously height is always perpendicular, okay? So my steps, we need to firstly identify and then highlight the face that you are going to use as the base. You'll then notice that there are edges that run away from the base, and any one of those will be the height of the prism. We're going to find the area of the base and then multiply this area by the height you identified in the previous. All right, so let's look at some examples. Well, firstly, let's just double check that we can highlight and identify what is the face that's going to be my base and what is my height. Now remember, this is a rectangular right prism. It doesn't matter which face I use as my base, but I've decided to go with this face over here. I don't mind how you highlight it. We obviously need that area, so the area of my base is just 4 times 10, which is 40 meters squared. All right, the height. Now remember what we said, the height is just an edge that runs away from the base. So you might say, well, hold on, there are 3 of them, and absolutely there are 3 of them, but it doesn't matter which one I choose because they all have a height of 12 meters. My volume, following the formula, is just area base times by height, so that is 480, and remember it's volume, so it is cubic meters. All right, let's look at an example of the cylinder, and what we have here is to remember we're going to highlight my base, and my base is a circle. So there we go, there's my circle. Remember, it has an identical one opposite it. And the area of a circle is pi r squared, so let's not forget that. My radius, there it is, there's 8. So we have pi times 8 squared. Now I'm just going to leave that as 64 pi. Don't worry about the units at this point. You want to put them in centimeters squared. I'm not going to get too stressed. Remember what we said, the height runs away from the base. So there, either that one or that one, it doesn't matter, they're both 14. There is the height of my cylinder, my right prism. Volume is therefore 64 pi times by 14. Now that is either 896 pi or, to 2 decimal places, 2814,87 centimeters, and its volume, so it's centimeters cubed. Right, well, let's look at the last example here. We're going to firstly identify the base, and remember, just looks like a Toblerone box. Here we go, chocolate again. The triangle has to be my base. I cannot use the rectangle underneath because all the cross sections that run parallel to that base rectangle get smaller as we go up. So remember, the area of a triangle, so the area of my base, area of the triangle is just half base times height. So remember, the base of the triangle, that's not the same as the base of the prism. The base of the triangle is just this base over here, and then the height of the triangle will be over there. Obviously, that's not the same as the height of the prism. Okay, so it's a half times 10 times 10, so 10 times 10 is 100, so that's going to be 50 millimeters squared. My height is the edge that runs away from that base, so there or there, either way, 13 millimeters. And my volume is therefore the area of the base times by the height, and 50 times 13 is 650. So we have 650 millimeters cubed. Right, you just need to do some practicing now.